Okay, in the following example, we have example 6.17, which is on page 263. And as we're doing this, the problem reads, a gas expands and does pressure volume work on surroundings equal to 325 joules. At the same time, it absorbs 127 joules of heat from the surroundings. Calculate the change in energy of the gas. So the equation that we're going to use is, so the equation, again, all the equations that are going to be necessary for the test are going to be on page 261 where it says key equations. The equation that we're going to use is the change in internal energy is equal to heat plus work. In doing so, now we have to pretty much understand what the problem is telling us. So the first thing that we're going to denote, we're going to denote it in green. We're going to say Q. And it says, and remember that Q is equal to heat. Okay. If they say, in this case, they say that it absorbs 127 joules of heat from the surroundings. So that means in this case, we're going to absorb 127 joules of heat from the surroundings. Now, if you remember table 6.1 on page 236, it says that if heat is absorbed by the system, then our heat is going to be endothermic, which means a positive value of energy. Okay? So in this case, we're going to have 127 joules of heat, and it'll be positive because you're absorbing this endothermic. Secondly, we're gonna look at the work. Okay, according to the problem, it's telling us that a gas is gonna expand, and it does PV work on the surroundings to equal 325 joules. So this time we're gonna say, well, work is, as the gas expands, the work is done on the surroundings, okay? So the work is gonna be done by the system and then on the surroundings. How so? Because the gas is expanding. So therefore, again on table 6.1, if work is, if the gas is expanding, that means it's going up this way on the piston. That means it's doing work against the system. The work against the surroundings. So therefore your sign is gonna be negative. So this, in this case, it's telling us that the work is gonna be 325 joules, but because it's doing it on the surroundings and by the system, it's going to be negative. So now all we have to do is plug in to determine our delta U. Our delta U is equal to the Q, which is going to be denoted in green. It's going to stay positive, 127 joules, and we're going to add the work. But here, if you notice, the work is going to be negative, so we're going to subtract 325 joules. As we do so, and we do our subtraction, we're gonna end up with our answer, which is change in internal energy, which is gonna be negative 198 joules. Sorry guys. Didn't mean to confuse you right there. Joules. Okay.